All right, my friends, for problem 2, it says graph each polar equation, support your answer with either t-table or algebraic analysis. So for both of these, it would make most sense probably to provide a t-table, probably the quickest and easiest way to go about it. So for part A, I'm expecting for you to show a spiral. A t-table, kind of a sample t-table that could make sense, would be where you plug in theta values and you get r out. So for example, if theta 0, r would be the opposite of 0, or 0. So that would turn into just plotting this point here at the pole. If theta is pi over 6, r would be the opposite of pi over 6, would be approximately -1/2, since pi is, a little bigger than 3. So anyway, so when you're facing pi over 6, you would go away from it about a half. When r is, let's see, how about pi over 2? R would be approximately -3 over 2, or -1/2. Okay. Let's see, let's go to when r is pi. When theta is pi, r would be, about -3.14, right? Since pi is about 3.14. So 1, 2, 3, just a little over 3. You could always, choose something in quadrant 2 as well. So, let's see, what would be good? 2 pi over 3 would be super good because the pi and the 3 kind of cancel. I know that sounds so horrible, but it's basically, you'd get something close to -2 there. A little bigger, I guess. Anyway, so you could add some detail like that. So far when you fill it in, you'd have something like this. Let's see, let's put in 3 pi over 2, so it'll be about 4.5, or -4.5. 1, 2, 3, 4.5. And then when you put in, let's see, 2 pi, you'd get about -6.28, so 5, 6, and a little more. There you go, and it continues like that, so a little arrow at the end, okay? Let's see, you're going to get 1 point for having a spiral. And then another point for having the spiral going in the direction that mine is going. So correct direction. And so the direction was basically created with that negative there. And then from there on out, I'm looking for at least 4 points of accuracy. So at least 4 points of accuracy. And so it's 1 point per point. So there we go. Okay. And that would be your 6 points there. Yay. Okay. Hopefully that went well for you. And then for part B here, you're expecting a limacon. You could play around with cosine being between -1 and 1. So if cosine's -1, its lowest value, you'd get an r value of 6. If cosine is +1, you'll get an r value of 2. So you're expecting something that basically goes from being 2 to 6 units from the pole. So, so I'm basically expecting like either the bean-shaped limacon or the little, like, what was it, convex limacon, one of those. And then to figure it out, I'm just going to circle the values that I'd plug in. So I'd plug in 0. For cosine, I would recommend doing the over 3s for each quadrant. And then pi, and then the over 3, 3 pi over 2, and then the over 3. And then if from there you don't know how to fill it in, you could always, use some of the other values. So, okay, so getting started here. Plug in theta, get r out. So if theta is 0, cosine of 0 is 1, you'd have 4 minus 2, so it turns into the 0.02. Let's see, let's put in pi over 3. Cosine of pi over 3 is 1/2, so you'd have 4 minus 1, which is 3. Pi over 2, cosine of pi over 2 is 0, so you just get 4 out. Let's see, let's put in 2 pi over 3. Let's see, cosine of 2 pi over 3 is negative 1/2. So you'd have 4 plus 1, which is 5. There you go. Putting pi in, we'd have cosine of pi is negative 1. 4 minus 2 times negative 1 is 6. So there we go. Okay. And so I would say a t-table, at least kind of justifying half of your curve, and then you could take advantage of symmetry to get the other half. So 2 pi over 3 corresponds to this point here, pi over 2 to this point here, pi over 3 to this point here. There we go. And then if you're not sure, what to do in the meantime, you could always plug in pi over 6. It's just not as fun. So cosine of pi over 6 is root 3 over 2. Times 2, you get root 3, which is about 1.7. 4 minus 1.7 would be 2.3. Let's see, 2.3. And that would happen down here as well. All right, so it looks like you've got a dimpled limacon or the bean-shaped one. Fill this in. It's kind of subtle there with that little dimple. All right. Okay. So you're going to get 1 point for having a limacon. You're going to get 1 point for having the dimple, or the bean shape. And then the other 6 points are for the points of accuracy. And let's see, how do we want to do this? Okay, we're going to do 1 point for plugging 0 in, 1 point for plugging pi over 2 in, 1 point for plugging pi in, 1 point for having a point of accuracy at 3 pi over 2. So that's 4, and then there are 2 more points, and so the 2 additional points are for a half a point for each of these, kind of having 1 point of accuracy somewhere in each quadrant. Having these points in each quadrant, okay? And I believe that adds up to 8. There you go.